great demands are placed upon them. Metallic materials should be hard, tough, and fatigue-resistant. Safety-related aspects play an important role, especially in the automotive and aerospace industries. But just how a material performs over the long term depends to a large extent on its degree of purity. Almost every metal bears impurities. Small, non-metallic inclusions that occur in the course of smelting and during processing. It is very difficult or even impossible to remove them by metallurgical means. If the component is later subjected to high stresses, internal cracking can occur, which can then lead to premature fracture of the component. In Freiberg in Saxony, experts are researching how the metallic components of the future can be produced defect-free and thus with greater stability. At the Technical University Bergakademie Freiberg, the team from the Collaborative Research Group 920 works on novel ceramic filtration materials and filtration systems for the purification of metal melts. These innovations should reduce non-metallic inclusions and increase the quality of the material immensely. The core of these experiments is the filter design. In an extensive series of tests, the scientists analyze materials, structures, and surfaces.
In terms of our collaborative research center, we would like to improve the filtration efficiency of filters. We have to apply a special coating on our filters in order to increase the filtration efficiency from 70 to 90%. We can increase the purity of the metals, as well as improve their mechanical properties, as well as to improve the recycling of metal.
Among other approaches, the scientists look for solutions in active filter surfaces. To this end, they take filter struts made of plastic foams and coat them with different ceramic materials. These can be used after a special drying and sintering procedure. If undesirable particles from the metal melt now contact the filter wall, they adhere to it and are thus separated out of the melt. If such particles encounter each other, so-called clusters can form. These also adhere to the filter and act as melt flow obstructions. Experiments are carried out in the laboratory under similar conditions to those during casting to find out which filter materials are really suitable.
We see a further approach in the development of reactive filter materials. These react with dissolved gases in the steel melt to non-metallic inclusions, which then get trapped by the filter wall. Thereby, a remarkable reduction of gas impurity is enabled. Particularly innovative in this case are both the layer composition and the functionalized filter surface.
To ensure successful application, the scientists in Freiberg examine the mode of action of the filter structures and study different microprocesses. They are assisted by physical models and 4D visualizations.
We use simulations to study the metal melt and heat flow, as well as the movement and separation of particles inside the filter. This knowledge allows us to find the optimal filter design and to shorten time-consuming tests in laboratories.
But can these novel filters withstand the stresses encountered during casting? They will have to withstand temperatures of 1,600 degrees Celsius in the future, as well as the mechanical pressure of the metal melt. Among other techniques, fracture mechanical tests at high temperatures show which filter materials are capable of withstanding such conditions. With the help of high-resolution testing procedures, the scientists can detect changes in the microstructure even during stressing.
In this way, we can draw conclusions about the processes taking place in the filter material. For example, if and when the microstructure undergoes changes or a crack arises. So it is possible to optimize the filter and improve the thermomechanical properties, because a good filtration at high temperatures is only guaranteed if the filter is dimensionally stable.
Based on further experiments, the scientists want to find out how effectively the new filter systems function. During the test smelting, they deliberately add non-metallic inclusions of different types and sizes. Now the filters have to show what they can do. The fewer inclusions the future castings contain, the more stable and resilient they will be.
The enhancement of the material properties due to the application of metal melt filtration techniques during casting is determined by different mechanical tests, for example by ultrasonic fatigue testing. Our first results show that we are heading in the right direction.
Sophisticated filtration systems for a new generation of materials. Innovative materials with a higher material efficiency and therefore that move energy and cost reductions into reach. A major advantage for Germany in the international marketplace. This major research project should deliver extensive knowledge about all aspects of these intelligent filters by 2023. 10 institutes of the Technical University Bergakademie Freiberg are working together intensively toward this goal. They are supported and assisted by the DFG, the German Research Foundation. This includes the training of highly qualified young professionals who are being prepared for their work in science by the opportunity to attain a doctorate. With the successful realization of the project, the Technical University Bergakademie Freiberg once again underlines its know-how in materials and technology research.